All right, for 6-6 notes, I think mine look a little bit different than yours, so please go to the blank page that says 6-6 and just go ahead and write these in for yourself. Okay, so in the 6-6 notes, we're looking at Pythagorean triples and reducing triangles. Okay, so for these examples, we're solving for x. Hopefully we can do these rather rapidly because you become an expert at Pythagorean theorem. Okay, so if I give you this right triangle, lengths of 3, 4, and ask you what the length of x would be, you should be telling me, filling in Pythagorean theorem, with the hypotenuse being the one that stands alone. 3 squared plus 4 squared equals x squared. Help me with the numbers. 9 plus 16 equals x squared will give us x squared equals 25. And when we take the square root, which I'm going to quit writing, okay, as long as we know that's what we're doing, we would get positive or negative, but you're only going to give me positive because it's a length. We would get x equals 5. All right, for number 2, here's another right triangle. Let's give you length of 4 and 5 and ask you what x would be if it was there. 5 is the hypotenuse that has to stand alone. So you should be giving me x squared plus 4 squared equals 5 squared. Help me with the numbers. X squared plus 16 equals 25. Isolate the x squared by subtracting 16 to get 9. Take the square root and x would be a length of 3. All right, the third one. Let's give you lengths of 3 and 5. Ask you the length of x. Again, the 5 is the hypotenuse. The long side is the one that has to stand alone. So Pythagorean theorem should say x squared plus 3 squared equals 5 squared. So x squared plus 9 equals 25. Again, subtracting the 9 to isolate the x squared, we would get 16. Take the square root and x would equal 4. Now, before we go on, notice, what did we just do in 1, 2, and 3? Actually look at the numbers, look at our lengths. So, for instance, we have 3 and 4, and our answer for x was 5. Here we had 4 and 5. Our answer for x was 3. Here we had 3 and 5. Our answer for x was 4. So what are you noticing? Hope you're noticing that 3, 4, and 5 always go together. Okay? Provided it makes sense for the picture, right? Thinking about the hypotenuse. So the longest side has to be on the hypotenuse. Okay, then in 4, if I give you 3 and x and 5, do you automatically know what x is? Test it. Test whatever you were thinking with Pythagorean theorem. 3 squared plus 5 squared equals x squared. So 9 plus 25 equals x squared. X squared equals 34. And therefore, if you take the square root, x would equal the square root of 34, which I'm thinking, trying to break down, that's 2 times 17. It just does not break down any further. Okay, because those would both be prime numbers. And so the square root of 34 would be the answer for x. Well, I bet some of you guys told me the answer was 4 when you were predicting it, because we said 3, 4, and 5 always go together, right? And we had these lengths of 3 and 5. But we also said it had to make sense for the picture, and that has to do with the hypotenuse, guys. So I purposely did this on purpose, so that you could see what's kind of coming up. So mathematicians have done this. You guys are mathematicians now. Mathematicians have done this enough times to know that 3, 4, and 5 always go together, provided 5 is the hypotenuse. The longest side has to be the hypotenuse. Okay? Since it was not here, right, 5 was sitting down here on one of the legs, that's why it doesn't go with 4. Okay, so 5 was down here as a leg instead of a hypotenuse, so it did not go with that. Okay, so x would be the square root of 34, and then we'll just go ahead and make a note here. So when you go back and look at your notes, you've got it. Why not x equals 4? Well, it's because c has to equal the longest side in Pythagorean theorem. Okay, so the 5 can't be a leg, it had to be the hypotenuse. All right, so then on that, thinking about some patterns, here's important stuff for us to remember. Okay, so first of all, here's our Pythagorean theorem over here, right? A squared plus b squared equals c squared. Why are they called squareds, right? We've talked about that before. So, like for instance, this is a 3 by 3, it's a square. All right, and then 4 by 4 square, and a 5 by 5 square. And notice, if you put them all together, they would make up this perfect right triangle in the middle with lengths of 3, 4, and 5. Okay. All right, so then you know how to use the Pythagorean theorem, right? If we put these numbers in down here, the 3 squared plus 4 squared equals 5 squared, or 9 plus 16 equals 25, and 25 equals 25. We've done that. Now, we've got these things called Pythagorean triples. Okay, and you're going to want to get, there are an infinite number of them. You're going to want to get some of these memorized. We're going to require you to get the first 5 memorized. Okay, so at least the first 5. And here's what you need to know. Okay, we just went through and showed you the 3, the 4, and the 5, and I'm going to erase that in a minute. We just said 3, 4, 5 makes a right triangle provided the 5 is the long side. It's got to be the hypotenuse. So think of these columns as the first column is a leg, the second column is a leg. The last column, since it's all the biggest numbers, has to be the hypotenuse. Okay, so there's your different columns. So now, automatically, if you see the 2 legs labeled 3 and 4, you know the hypotenuse is 5. You're welcome to just say the triple is 3-4-5, and I don't even have to do the Pythagorean theorem. Okay, so some of you guys are going to like this because it's going to give you some shortcuts. The next one is 5, 12, 13. Okay. The next one, 7, 24, 25. So for instance, if you knew a leg was 7 and the hypotenuse was 25, you automatically know the other leg is 24. It will work that way every single time. That's what the Pythagorean triples do for you. Then you've got 8, 15, 17, and 9, 40, 41. Those are the 5 you're required to memorize. Okay, if you're ever wanting to memorize some of the others, this is another one that a lot of people memorize, is the 20, 21, 29. Okay, but there are actually an infinite number of these guys because any multiple of a triple, that's this statement down here, any multiple of a triple is also a triple. What we mean by that is I can take any of these and multiply by something. Let's say I multiply all these by 2. Well, 2 times 3 and 4 and 5 would give us 6, 8, and 10. So 6, 8, 10 is a triple. All right? Likewise, it could be, doesn't have to be such an easy number. It could be a root. How about root 5? So if I take root 5 times all of those, then 5 root 5, 12 root 5, and 13 root 5 are another triple. Okay, those make up another triple. All right, so get those first 5 memorized, and you're going to see the benefits of it and how it's going to help you make some shortcuts. Okay, now the next things that we are supposed to have memorized, right? We listed these out ourselves. Memorize these list of perfect squares. Okay, so that again, if somewhere in a problem like the word number 324 comes up, you're not sitting there trying to do a factor tree and break it down. You just know the square root of 324 is 18. Okay, Again, just trying to give you some shortcuts, not have you have to depend on your calculator so much. And then the things that we've said over and over, don't forget your notation here. Squared and square roots undo each other. So these two notations don't do each other, just giving you back the 3, which is the same thing as saying root 3 times root 3 is 3, and root 7 times root 7 is 7, and so on and so forth. Okay? All right, so let's practice using our reducing and triples. So if I tell you in the directions, use reducing and triples to solve for x, you must show that sort of work. Okay? Don't just try to use Pythagorean theorem. Go with the big numbers, okay? Because we're actually testing the method, okay? The reducing and triples. So here's what we would expect to see. Maybe some color coding will also help you, those of you that do color coding with me. Okay, so I'm going to make everything in my original problem purple. So let's say that I give you sides of 100, x, and 300. Now, Pythagorean theorem says that x squared plus 100 squared equals 300 squared will work. But guys, 300 squared and 100 squared are pretty big, right? You're going to have some big numbers. So we're using the benefit of reducing to help us. Okay, I'll do that in a different color. So I'm going to reduce 100 and 300 by, what's the biggest number we can think of that goes into those? Okay, if you're thinking 10, go bigger. Reduce by 100. You want to reduce until these don't reduce any further. So by that I mean this would turn into 1. 300 divided by 100 is 3. Notice 1 and 3 don't reduce any further. Okay, so keep reducing until they don't reduce any further. And now, guys, ask yourself this question always after you reduce. Ask yourself if there are any triples. Okay, so I'll write it so that you try to remember to ask yourself. So what I mean by that is, if you went to your triples list, is there a list with 1 as a leg and 3 as the hypotenuse? So 3 has to be in this big column. And there is not. No. So you're going to go on and do this. You're going to take the smaller numbers. Notice I'm purposely doing it in red. 1 squared plus x squared equals 3 squared. Let's solve. So 1 plus x squared equals 9. X squared would equal 8 if you subtract 1. If we take the square root of both sides, square root of 8. Break that down for me. It would be 4 times 2, and therefore 2 root 2. Take more steps to write that if you need to get that correct. And now, guys, most people at this point just want to box it and go on, but purposely that's why I'm doing it in color. I am not asking you for the red X. I am asking you for a purple X, okay? To get the purple X, you have to undo what you did at the start. At the start, you divided by 100, and therefore, to finish up, you need to multiply by 100. That's how you're going to undo it. And therefore, x will equal, now this is, do you remember how do you multiply roots? Okay, remember 100 has no root with it, so the root 2 is just going to stand alone. The numbers in front will multiply to be 200 root 2. Okay, here's your final answer for 5. All right, we just need to keep going and doing that process, I think, over and over a few times for you to kind of get it down. All right. Purposely, I'm just going to make the triangles start looking a little bit different. It shouldn't throw you off, though, guys, as long as you're focusing on where the right triangle is or where the right angle is. So on this one, let's give you lengths of 4, 4 root 2, and x. So which one's the hypotenuse this time? Right. Across from the right angle would be the x. Okay, so now again, I know 4 and 4 root 2 aren't huge numbers, but the directions said you had to use reducing. Okay, so it'll keep you in that mode. Ignore the root 2, guys. Ignore any roots. Just look at the numbers in front. If we reduce 4 and 4 by 4, this will turn into 1. This will turn into 1 root 2, so just root 2 since we don't write the ones in front. You're going to ask yourself the same question every time. Are there any triples? Okay, that would mean, are there any triples with 1 as a leg and root 2 as a leg? Well, I know if there's going to be roots involved, guys, based on the ones that we just talked about earlier, is that they would all have to have root 2. Okay, so that's a quick no. And therefore, I'm moving on with Pythagorean theorem using my smaller numbers. So you should have 1 squared plus root 2 squared equals x squared. Okay, 1 squared is 1, root 2 squared is 2. Therefore, x squared equals 3, and x would be root 3. Again, I need the purple x, not the red one. So root 3 doesn't break down any further. At the start, I multiplied by 4, and therefore to undo it, I need to multiply by 4. So my purple x is actually 4 root 3. Okay, 7. There we go. Let's give you 24 root 3 for this side. 10 root 3 for this side. And x. Again, which one's the hypotenuse this time? Should be the x because it's across from the right angle. All right, so here we go, guys. Use reducing and triples. All right, so again, I'm ignoring the roots. I'm just looking at the 24 and the 10. What's the biggest number that goes into 24 and 10? And if you don't pick the biggest to begin with, guys, which will happen some while we're doing maybe some homework and stuff, you just keep reducing. So that will come up. Ask me to talk to you about that. All right, 24 root 3 divided by 2 would be 12 root 3. 10 root 3 divided by 2 would be 5 root 3. Okay, notice the 5 and the 12 don't reduce any further, so that's how you know you picked the biggest number. The next question you ask yourself always is, are there any triples, right? Okay, are there any triples? So I'll write it because you want to remember to ask yourself that. So any triples? When I'm looking for triples, guys, as long as the roots match, since they're both root 3, I just ignore them and look at 5 and 12. So go to your triple page. Is there a triple with 5 and 12 both as legs, right? And I hope you're going to tell me, yes, there is. All right, so watch this then. Here's the work you show me now. Instead of doing Pythagorean theorem, you're just going to tell me the triple is, it's always in order, guys, with dashes between it. You're going to tell me the triple is 5, 12, 13, and therefore you can automatically jump to telling me that x equals, I'm purposely making it red, you're automatically going to tell me that x equals, well, if one of them is 5 root 3 and the other one's 12 root 3, then following the pattern, x would have to be 13 root 3, right? Because they all have to be multiplied by the same number. But I don't want the red x. I want the purple x. So at the start, I divided by 2, which means to undo that, I need to multiply by 2. And therefore, x equals 26 root 3. Okay? You can do Pythagorean theorem to prove it to yourself, but guys, get used to the triples. We're trying to make it shorter for you. Okay? So notice I will quit probably writing, are there any triples, and just start asking myself that. Okay, so I wouldn't actually end up with that in my work. All right? Last one. Let's try one more. So for 8, let's give you this picture, 16, 30, and x. Okay, why don't you see what you can do and come back. All right, so here we go. Reducing by 2 would produce 8 and 15. 8 and 15 don't reduce any further. So my next question to myself always is, Is there a triple with 8 and 15 as legs? And you should be getting them memorized as quickly as possible to be able to tell me, yes, the triple is 8, 15, 17. So this is the minimum amount of work you can show me. When I ask you the triple, that's what I expect you to write. Okay? But as far as work, you write down, oh, the triple is 8, 15, 17, and therefore I know the red X is automatically 17. But I don't want the red X, I want the purple one. So to undo what I did at the start, I divided by 2, so I need to multiply by 2. And therefore, the purple X equals 34. Okay, so those triples, guys, don't resist them. Use them to your benefit. The reducing also. Okay, that's faster than Pythagorean theorem once you get that stuff memorized. Okay, so do a good job getting those memorized and use them.